Number 3, question number 6, where the equation is x squared y prime plus xy equals y cubed over x. Okay, we're going to use Bernoulli's method and the integrating factor method, and we're going to use the change of variable equation. Okay, so what we're going to do first is divide by x squared minus by xy, moving everything over to the other side. And we're going to move this x over and make it x to the negative 1. So in doing all this, we're left with y prime on the left side equals negative 1 over x y plus x to the negative 1 over x squared y cubed. And we're going to use n equals 3, which is the highest power here. And this is going to be our a of x for the change of variable method. And this is going to be our f of x. Our change of variable equation is going to be z prime equals 1 minus n times a of x times z plus 1 minus n times f of x times z, or times f of x. And our z is going to equal y to the 1 minus n power. So z prime, as we see here, z is going to equal y to the 1 minus 3, which equals y to the negative 2. We're going to have 1 minus n, which is 3, a of x, negative 1 over x, which was here, times z plus, again, 1 minus n, which is 3, f of x, which is here, x to the negative 1x squared. Simplify here. So 2 over x, because negative 2 times negative 1 is 2 over x, z minus negative 2 x times x to the negative 1 over x squared, or z prime equals, and then we're going to set it into the integration factor method equation. So we have z minus 2 over xz equals negative 2x to the negative 1 over x squared. And our integrating factor is going to be e to the integral of negative 2 over x dx, which is equal to e to the negative 2 natural log of absolute value of x. Simplify it further, e to the natural log of x, absolute value of x, all to the negative 2 power, which equals x to the negative 2, which equals 1 over the absolute value of x squared, which is the same as 1 over x squared, which is our integrating factor. Then we plug in the integrating factor, multiplying it to both sides. So 1 over x squared times z prime minus 2 over x z equals 1 over x squared times 2, negative 2x to the negative 1 over x squared. And then as we can see here, we're going to rewrite it like this. 1 over x squared times z equals negative 2x to the negative 1 over x to the 4th. And then we get the integral of both sides. Integral of the derivative cancels, leaving us with 1 over x squared times z equaling the integral of this is going to be 2 over 4x to the 4 plus c. And we multiply by x squared here on both sides, canceling this out. Multiply by x squared. And I'll continue up here. So we're left with z equals 2x squared over 4x squared plus cx squared. And remember, we're going to put them back into xy format. Remember, z equals y, 1 minus 3, which equals y to the negative 2. So we're just going to plug that in for z. So y to the negative 2 equals 2x squared over 4x squared plus cx squared. And one extra step that we're going to do here is have them left in the same format. Have the right side here on the same format, leaving us with y negative 2 equals 2 plus 4 cx squared all over 4x squared. And we did that by multiplying 4x squared here over 4x squared. This is actually 1, so we're left with this after we go ahead and plug that in. So we are left with y negative 2 equals 2 plus 4 cx squared all over 4x squared. Well, we want to simplify. 1 over y squared equals 2 plus 4 cx squared over 4x squared. And we're going to flip everything over. So y squared, flip the other side over. So 4x squared over 2 plus 4 cx squared. Simplify even further by doing the square root of a square, which leaves us with y equals the square root of this side as well, which will leave us with plus or minus the square root of 4x squared over 2 plus 4 cx squared. And that is our solution right here.